Hello, my name is Victor Alejandro Hernández Canepa, and I'm going to talk about the ethanol diffusion in the automotive industry. First of all, we need to know what component we are going to evaluate. First, the component, it will be the ethanol that is provided for natural resources such as fermentation of sugars and hydration of ethylene. This component has so many uses such as cosmetics, beauty products, disinfectants, and gasoline. In the automotive industry, ethanol is one of the components of biodiesel, a synthetic biofuel in liquid state obtained from natural lipids. It is essential because it is natural, renewable, and clean food with the objective to reduce greenhouse gas emissions. Using this kind of biodiesel, it secures the car security because it increases 100% of the longevity of the car and not only reduces the gas emissions, it reduces the cost of maintenance of the car. So having biodiesel in your car, it will be very essential with that. But it is not prepared correctly with the correct measurement and quantity of the component. It will have a reverse effects in the motors because it will produce some malfunctions that it will cost more than having a normal fuel in the motor. The objectives that we are going to evaluate, it will be to calculate the time of diffusion of the ethanol air and determine the diffusion with the temperature given. The problem to solve is the next. The company named Grima Diesel oversees producing biofuels using as primary component ethanol. They have a group specified for the ethanol that are reserved them in tanks. In total, there will be 10 tanks of ethanol that use them in a specific amount of time. In the last few days, the company presented problems with some associates because the efficiency in their engines was not the same, and the emissions of toxic gases increases. The company decided to investigate what was the problem, and after checking each part of the company until they searched in the ethanol tanks reserve room, they verified that some tanks has less volume than the new ones after checking them. So they began with the investigation, knowing that the vapor pressure is 0.48 per atmospheres and the ethanol had contact with air, and the difference of the volume went from 0.9 meters to 0.84 meters of ethanol. For this problem, we are going to use the next approaches. For the assumptions, we estimate that the tank is in a steady state. The component B is stagnant, that component B is air, so there will be no reaction. The diffusivity occurs only in one direction, so we calculated in Cartesian coordinates and the movement in Z, and the diffusion, density, and concentrations are constant. And for the equations, first, to estimate the diffusivity, we use the Hirschfeld equations for non-polar and non-reactant and mixtures. And it is correlated with the collision diameter and the collision integral. After estimating the diffusivity, we estimate the differential of the flux, knowing that we need to calculate the differential of the molar fractions and the difference of sets, and knowing that in the equation 5 the flux is equal to the density between the molar weight of A, that will be ethanol, and using the equations 4 and 5 we can estimate the time. For the solution of the problem, we are going to divide it by two parts. First, we need to estimate the diffusion of ethanol air. Using the Hirschfeld equation and knowing that the temperature of the system is 310 Kelvin and we are operating at 1 atmosphere, and knowing the molecular weights of ethanol and air, that it will be 44 grams mole and 29 grams mole, we need to estimate the collision integral and the collision diameter. For the collision diameter, we estimate the values of each one of the components and calculate the average. While the collision integral is a little bit of complex, first we need to know the energy molecular interactions, that it will be the same image as the collision diameters. We estimate we multiply both of them and have them square rooted. Then when we inverse them and multiply them with the temperature, so we have the value to estimate the collision diameter in the table 1 that will be represented in the image 1. So after doing all these calculations, we estimate that the diffusivity is 0.1283 centimeters squared between seconds. For the second part of the solution of the problem, we estimate the time using flux. First, we use the general equation knowing that there is only the differential of the flux of ethanol between time equals 0, so is constant. After that, we use the first fixed law to estimate the differential of sets and the differential of molar fractions, knowing that the molar fractions of B that we will air is stagnant. So after integrating them and estimate the value of the flux of ethanol in set, we equate them with the equation 5 that will be the density between the molar weight of A per the differential of sets and the differential of T. And we estimate the time after equating both equations. After doing the calculations, we estimate that the ethanol tanks have the time to diffusion for 31.25 days. In conclusion, the tanks of ethanol were opened for 31 days, so the ethanol has lost some volume when the company have contact with air. Some difficulties that were given in the project were the estimation of the diffusion of ethanol air, because it depends on the pressure and concentration, so it can vary the results. But this situation of the tanks of ethanol exposed in the air makes the company Grima decide not only to buy more ethanol to substitute the older tankers. It is important to understand the diffusion implications in this industry, and not only of that in daily life, because this kind of error made the Grima diesel company not to pay a fee to their associates, because it cannot only cost economically, it can endanger people that are using its motors. And here are my references. Thank you everybody to hear this presentation.